Good afternoon, children. Today we will discuss another important topic, that is mass and weight. So far we have discussed earlier in previous chapter that mass is the measurement of inertia. So greater mass, greater inertia. Similarly, the mass of an object is constant. Mass does not change whether the object is on the earth or on some other planet. So we can say that mass is the quantity of matter contained in an object. So if you have to define mass, you will say that mass is the quantity of matter that is contained in a body. Now, mass is a scalar quantity, and SI unit of mass, as you know, it is kilogram. Another important thing about mass, that it is constant everywhere, isn't it? And for measurement of mass, we are using beam balance. On the other hand, weight is a force. Weight is a force by which earth attracts an object towards its center. So in case of freely falling object, while we are writing force is equal to m into a, where a is the acceleration. So in case of freely falling object, this acceleration a is replaced by small g, that is acceleration due to gravity, the force by which earth attracts the object towards its center, and earth produces an acceleration that is equal to g. So our expression changes, that F is equal to mg. Now this force by which earth attracts an object towards its center, this force is the weight of an object. So we can write W is equal to mg. So this is the definition of weight, and as you know, weight is not constant. It changes from place to place because the value of g is not constant everywhere on the earth. Another important thing that we use is spring balance to measure weight, and weight is a vector quantity. So let us discuss this topic, mass and weight, by knowing the differences between them. And this question is very important question. Mass and weight. So you draw a column and write down the differences. So the first point you will write, the quantity of matter contained in an object is called its mass, isn't it? The quantity of matter contained in an object is called its mass. Similarly, For weight we will write the force by which the earth attract an object towards its center is called weight of the object. So these are the definitions for mass and weight. For weight we have written the force by which the earth attract an object towards its center is called weight of the object. Then we can write that mass is a scalar quantity. For weight we will write weight is a vector quantity. Because we have written weight is a force, a type of force, so that's why we are writing that weight is a vector quantity. Then write their units, that is also a difference. So SI unit, as you know, SI unit of mass is kilogram. Then weight side, since weight is a force, so what is the SI unit of force? You all know the SI unit of force is Newton. So write SI unit of weight is Newton. Then think about the fourth difference. Mass is constant everywhere. The quantity of matter contained in an object, it doesn't change. It is constant. Where you are on equator or you are on pole, you are on some other planet, your weight will change, but mass is constant. Then for weight you write weight of an object depends on g, acceleration due to gravity, and hence changes from place to place. So this is the fourth difference. Now fifth one. Fifth one, how we can measure mass? So right, we can measure mass with the help of beam balance. And for weight you will write we can measure weight with the help of spring balance. So these are the differences in children. And these differences are very important. You must note down these differences in your classwork copy and learn it. I think as you know, these differences are simple. First, you know the definitions of mass and weight, and mass is scalar, weight is a vector. Then SI unit, as you know, for mass it is kilogram and for weight it is Newton. Mass is constant everywhere, the quantity of matter will not change, whereas weight depends on acceleration due to gravity, and as we know the g changes from place to place, that's why weight is not constant. Then fifth, we can measure mass with the help of beam balance, whereas we can measure weight with the help of spring balance. Now children, we will discuss a question, important question. First write it. This is question number 1. How does the weight of an object vary with respect to mass and radius of the earth? Then second part, in a hypothetical case, if the diameter of the earth becomes half of its present value, and its mass becomes 4 times of its present value, then how would the weight of any object on the surface of the earth be affected. So let us try to answer this question. So as we know, weight of an object is directly proportional to mass of the earth. It does not depend on mass of the object. It depends on mass of the earth and inversely proportional to the square of the radius of the earth. So right, in answer you will write, we know that weight of an object is directly proportional to mass of the earth and inversely proportional to the square of the radius of the earth, isn't it? Because as we know, weight of a body, in rough I am doing this just so that you can understand. We have read earlier, I am saying that F is equal to ma. We are familiar with this expression. Force is equal to mass into acceleration from Newton's second law of motion. In case of freely falling object, this acceleration is replaced by letter G, acceleration due to gravity. Now when we are defining weight, we are saying that weight is a force by which earth attract an object towards its center. So we can write this force is exerted by the earth on freely falling object towards its center. That is, this force is equal to weight of the object, isn't it? And this G, as we have learned earlier, this is G is equal to Gm by R square. That's why we have written that weight of an object is directly proportional to mass of the earth, where m is the mass of the earth, and inversely proportional to square of the radius of the earth. So we can also write that W is equal to mgm by R square. So we can write weight of a body is proportional to m by r square. Now, as we know, original weight on earth, original weight on the earth, if we represent it by letter WE, we can write mg. Weight, now we have written weight is equal to mg, and this can be written as mgm by r square, because earlier we have derived this relation that g is equal to gm by r square. When we are deriving a relation between small g and capital G, we have derived this relation. So we can write now, according in a hypothetical case, the diameter of earth become half of its present value and mass becomes 4 times. So according to question, now according to question, mass becomes 4 times, it means 4m, and diameter of earth becomes half. So if diameter will be half, radius will also half, and r becomes r by 2 according to our question. The mass becomes 4 times its present value and the diameter of earth becomes half, so radius also decreases to half. So now calculate the weight. So therefore weight of object on the earth will be, it will be m g. In case of this m, we will write now 4m and r by 2 whole square, isn't it? So if you will simplify, it will be m g 4m by r square by 4. Now further this can be written as, this 4 will go upside, so it will be 16 mgm by r square. Now this is equal to you can also write, you have to calculate the weight in a hypothetical case if the diameter of earth becomes half of its present value and mass becomes 4 times. So we can write it as new weight. New weight, otherwise there will be a confusion. We are calculating new weight when mass becomes 4 times and diameter reduces to half. So this new weight will be 16 times the original weight, because this WE is equal to mgm by r square. So this quantity is equal to weight on earth, so we are writing 16 into WE. So you can write the weight becomes 16 times, hence the weight becomes 16 times. So this is one of the important question. write it, and if you have any doubt you can ask me. In my personal WhatsApp number you can raise your doubts. Now, children, we will discuss another important question. I think you all have written. The second question. Okay, first write the question. And must write all these things in your classwork copy. The notes which I have given or the questions which we discuss in our classes, the questions are important. Now write this question. Mass of a body is 5 kg. What is its weight? Question 2. Mass of a body is 5 kg. What is its weight? So, very simple question. Mass is given 5 kg. You have to calculate weight. So as we know, weight is equal to mass into acceleration due to gravity, mg. So if value of g is not given, you will take 9.8. As you know, value of g is 9.8. So multiply it with 5. 8 5s are 40. So 5 9s are 45 and 4 49. So 49 Newton is the weight. In this way you have to calculate the weight of an object if mass is given. You can get a question in which they can ask it in a reverse way also, that weight of an object, if I ask in this type also, that weight of an object is 49 Newton. Find its mass. So this type of questions you can also get. So very simple, weight is given 49 Newton. You have to calculate mass. So we will write weight is equal to m into g. Therefore, m mass is equal to weight by acceleration due to gravity, weight by g, and weight is 49 divided by 9.8. We are taking 9.8 value of small g. So if you will simplify 490 by 98, after removing decimal, 49 twos are 10, so 5 kg. Just reverse of it. Must write these answers in your class copy. And today is your unit test. My good wishes to you. All the questions which I have asked is based on the previous topic which we have learned in this chapter, that is Newton's law of gravitation and acceleration due to gravity and the free fall. So the questions are from these topics only. Now we will discuss the next question. Now the next question, question number 3. Question number 3 is, how much would a 70 kg man weighs on the moon what would be his mass on the earth and on the moon? Now for this question, acceleration due to gravity on moon is given 1.63 meter per second square. This value is given. Now first of all, mass of man is given. So mass is on moon how much would a 70 kg man weighs on moon? So mass of man is given 70 kg. You have to calculate its weight on moon. I am writing Wm, weight on moon you have to calculate, and mass of man is given 70 kg. So no new formula for it. Weight on moon will be mass into acceleration due to gravity on the surface of moon. Simply weight is equal to formula m into g, and here we have taken weight on moon, Wm means, and gm means acceleration due to gravity on the moon surface. So substitute the values. Gm is also given, acceleration due to gravity on moon surface is given in the question, 1.63 meter per second square. So multiply 70 into 1.63. So if you will multiply, it will be 21 to and 44 4 11. So 114.10 Newton. So weight on moon will be 114.10 Newton. Now, so first thing we have calculated what would be his mass on the earth and weight on the moon. So weight on the moon we have calculated. Now mass on the earth and on the moon. So mass on the earth is 70 kg. So you will write, since mass on earth is 70 kg, so on moon it will also 70 kg, because mass is constant everywhere. That is important point, children, that mass will not change whether the object is on the earth surface or on the moon surface, because quantity of matter contained in an object is always constant. So its mass will be 70 kg on moon also. So in this way you have to solve the questions. Now we will discuss some other questions. Now question number 4. Write this question, children. Consider a heavenly body whose mass is twice that of the earth and whose radius is thrice that of the earth. What will be the weight of a book on this heavenly body if its weight on the earth is 900 Newton. So recall the formula for weight first, children. So we know that weight on earth is equal to mg, and this can be written as further m. For g we can write gm e by re square, isn't it? So this is weight of an object on earth's surface. This is the weight. Now suppose weight on heavenly body, what will change? Mass and radius will change. So write weight on weight on heavenly body is W dash, so we can write m g, then let the mass of the heavenly body is m dash, and radius of heavenly body is r dash. You can also write where m dash and r dash are mass and radius of heavenly body. So suppose this is equation 1 and this is equation 2. So if we take the ratio of these two, suppose we divide equation 2 by 1, take ratio w by w dash, w dash by w, so it will be m g m dash by r dash square, and you can write it in this way, then it will be clear to you. And this is m g m dash by r dash square in numerator, and in denominator we have m g me by re square. Now this can be further written as m g m dash by r dash square into re square by m g me. So small m cancel, capital G cancel. So you will get m dash r e square by r dash square into me. Now consider a heavenly body whose mass is twice that of Earth. So according to question, mass is twice that of Earth. So m dash is 2m. This is according to question. And radius is thrice that of Earth. It means r dash is 3re. These are according to question. So we will substitute these values. So write m dash is equal to 2me by re square, and here for r dash we will write 3re square. So 3re square will be 9re square into me. So if you will simplify, so me cancel, re square cancel. So w dash by w is equal to 2 by 9. Better to write it as we, because earlier we have written weight on Earth. Now it is given its weight on Earth is 900 Newton. This is 900 Newton. So we can write or w dash is equal to 2 by 9 into we. So it will be 2 by 9 into 900. So if we will simplify, so it will be 200 Newton. So the weight of book on heavenly body will be 200 Newton. So these are the possible types of questions, children, which we have discussed today. All these questions are important regarding mass and weight. In next class, we will discuss weight of an object on moon. And best of luck for your unit test, children.